Every variable in a data set is either numerical or categorical. If a variable is numeric, it can further be divided into continuous and discrete. A continuous variable can take a value at any point in some interval. Like maybe you're modeling the lengths of pieces of rope, and the length can be anywhere between 70 and 75. That means it can be 71, it can be 72.3, it can be 73.778931 dot 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 on and on forever. It can be anything in this interval. In reality, these things aren't quite continuous because we're limited by the precision of our instruments, but they're close enough to continuous that we can model them that way. A discrete variable can take on a countable number of values. Some elementary stat books say a finite number of outcomes because they don't want to get into what countability means. But the problem with that is that there are a lot of discrete distributions that have an infinite number of possible outcomes. For this class, think of a discrete numerical variable as a variable that takes on n possible outcomes where n is either an integer like 1, 2, 3, 4, 5, etc., or it's infinite. And most of the time, discrete variables are used to count things like in these examples here. Variables that aren't numerical are categorical. They can be fit into some types of categories. Nominal categorical variables don't have an order, like chocolate, vanilla, strawberry aren't in any kind of order. But small, medium, large are in an order, and these are called ordinal variables. This isn't a distinction that we'll spend a lot of time on, but I do want to make you aware that sometimes categorical variables can be confused with discrete numerical variables. Like if you roll a die, should you treat the number that comes up as a discrete numerical variable that takes on the values 1 through 6, or should it be categorical with 6 categories? It really depends on what those numbers mean. For a numerical variable, distance should always mean the same thing. In other words, the difference between 4 and 3 should be the same as the difference between 6 and 5. If there's some room for interpretation about what the distances between numbers mean, then you've got a categorical variable. Another type of variable we need to be aware of is the confounding variable. We use random sampling to negate the effects of confounding variables. But when we observe data, when our experimental units were not randomly assigned to the treatments, then we may run into problems with confounding. Here, researchers have noted that women who don't smoke are 40% more likely to have a child with Down syndrome. Does this mean that the mother smoking prevents Down syndrome? No, because older women are more likely to have children with Down syndrome, but less likely to smoke. So the mother's age is a confounding variable. Here's some data that I simulated. It's not real, I just made it up to show you how the math might work. Notice that 10% of young women have Down syndrome births regardless of whether they smoke. So here we have 4 out of 40 for the smokers and 16 out of 160 for the non-smokers. So it's 10% whether or not the young woman smoked. Also, we have 20% Down syndrome births among the older women, regardless of whether they smoked. Again, 2 out of 10 is 20%, 18 out of 90 is 20%. So smoking doesn't appear to be affecting anything. If you're a young woman, the probability of having a Down syndrome birth is the same whether or not you're a smoker, and the same with the older women. Since younger women are more likely to smoke than older women, this leads to more Down syndrome births among women who don't smoke than among women who do. So it appears that smoking is reducing Down syndrome births. We actually can't tell just from this data what's going on. Maybe smoking is reducing Down syndrome births, or maybe they increase with the mother's age. If we could randomly assign these women to smoke, we could perform an experiment rather than an observational study. This would allow us to reach a conclusion about how smoking affects Down syndrome births. And as they say in the textbook, we can only infer causation from a randomized experiment. That is, an experiment where subjects were randomly assigned to a treatment.